we are going to look at a mechanism which is capable of plotting polygonal spirals. Now, what do we mean by polygonal spiral? Well, it's not like an ordinary spiral that is just a smooth curve that is opening out, but rather a jagged curve like this, okay, made up of straight lines. And you can see this curve is sort of hexagonal, but it is not a closed polygon, closed hexagon, but it's a hexagon whose sides are slightly longer and longer than the previous one. And therefore, it keeps opening out, spiraling out like this. So we can call this as a hexagonal spiral. Moreover, I can say that the pitch between the distance between two successive straight edges like this is going to remain constant. So it is a arithmetic or Archimedean spiral. Okay, so the sides are increasing with a certain increment, certain fixed length is getting added every time. Okay, let us see how this mechanism works. This mechanism has two essential parts. One is this red link, you can see this angular link, and it has a special angle here. We'll see how to calculate that later. But this arm of this angular link also has a slot, and within that slot there is this pencil which will be able to move and trace some path. The second part of the mechanism is this central hexagon or this disc here, which is capable of rotating, and it has these two extensions or whiskers or wires, if you want to call them, and they are going to limit the movement of this pencil. Okay, so let's see how this mechanism works. It works in two phases. In the first phase, the pencil moves in a slot and traces the straight line, the edge. And in the second phase, the pencil will remain stationary and the central disc would rotate. As it rotates, this red link is going to slide within it and the pencil is going to get anchored. So the pencil is going to guide this slotted arm. Okay, so let's see how that happens. So this is the rotation phase. You can see the pencil is anchored. It is not moving at all. In fact, it is working as a guide. So this is the rotation phase. Again, the mechanism is aligned. So we are ready for drawing our next straight line. So let's do that. And now it's the phase of rotation. So anchor the pencil, move or rotate the base. Again, trace the line. Then move the base and so on. Okay, so this is how the mechanism works. Half the time it is rotating, half the time it is tracing the curve. Alternating phases. So part of the time the pencil is working as a simple tracer, something that draws a line, and half the time it is integral part of the mechanism. It is actually getting anchored and it is guiding the mechanism. Okay? And here there is no limit to the number of sides you can have. This happens to be a hexagonal spiral, but simply by changing this angle, you can make it a pentagonal spiral or a square spiral or a heptagonal spiral or even a triangular spiral. So there is no limit to the number of sides n that we can have in this polygonal spiral. Let's now change the mechanism a little bit. So here you can see this angular link that we had, the red one. This angle has altered. Otherwise, the mechanism is same. Okay, there is a central base that will rotate. There is a pencil that will either trace or anchor and guide the mechanism. So let's see what it gives us this time. Here is the tracing phase, the rotation, again tracing, rotation, tracing, and rotation. And you can see now we are getting a square spiral. And looking at this square, if we stop this mechanism at say this phase here, you will see this arm of the angular link is parallel to the diagonal, while this is parallel to the side. Okay. So the angle here is going to be half the internal angle of the polygon we are tracing. This happens to be a square, so this angle is 45 degrees. So with 45-degree angle, we will get a square spiral. Again, you can see the distance between these successive arms of the spiral over here. This is going to remain the same. Okay, so this is a Archimedean polygonal spiral. And finally, we will watch just one more value of n, just one more variation here. So the moment I trace two of the sides, you would know the angle, and from that probably you can guess what is it going to be. So have you guessed it already? Or by now you should know. It is a pentagonal Archimedean spiral. So here the basic working is the same. See, the external angle for a pentagon is 360 upon 5, that is 72. This is its supplementary angle, so 108, and we are taking half of that, that is 54 degrees, for our angular length. So that's the only variation we make. Rest of the things remain the same. The same two parts, okay, the angular link and the central rotating disc, the two whiskers, the slotted link, everything else is going to work the same way. Here you can see the distance between this straight line, and this straight line. That is a constant. So that is why we call it a arithmetic or Archimedean spiral. There is a arithmetic progression of lengths. As against that, there will be geometric spirals where instead of having a constant increment, constant addition, we will have a constant multiple. Okay? So that we'll see in another mechanism.